put the hood up on here, kind of like you put the hood up on your car. Okay, so this is the infrared, mid-infrared spectrometer we're going to be using. This is a dispersive instrument, so this uses a grating-based monochromator. This is not a Fourier transform instrument. If you look back through this window, you can see kind of a red glowing object. That is our infrared source. And so this is the glow bar. It's a source of infrared energy. The monochromator that we use to select the wavelength, this is the monochromator. So this is the diffraction grating right here that disperses the energy. And so the light from the source comes through, it's dispersed, it's focused then on individual wavelengths are focused on the detector, and then this is the detector that measures the intensity of the light after it passes through the sample. Okay? And so the grating here will be rotated, and that's how we select the wavelength or change the wavelength or wave number of radiation that we're passing through the sample. So again, this is a monochromator-based instrument rather than an FT instrument. So the first thing we do when we get ready to collect the spectrum, just like we did in ultraviolet or visible spectroscopy, we have to run a blank or a background spectrum. And in infrared, we're just going to run it against the air. So we're not going to use a solvent, excuse me, we're just going to collect the background spectrum of the air. So everything is controlled over here through the laptop computer. So we're going to do our reference or our background scan. We're going to scan from 4,000 wave numbers down to 600 wave numbers. And so we'll see then the background scan, just the blank scan with nothing in the infrared beam. One of the reasons we do this is we can actually see absorptions due to the water vapor and the carbon dioxide in the air. So there's carbon dioxide in the air, there's water vapor in the air, and those will actually absorb. And so what we do is we record the background scan, and then we subtract out those absorptions due to the water vapor and the carbon dioxide. Okay? While we're scanning the background, you can go